the apothem times the perimeter. Can you tell me the value of the apothem from the drawing there?
That'd be 5.5, right?
It is 5.5. The perimeter is going all the way around here, and it looks like it's 8 for each of those. So that would be 5 times 8, 5 sides.
Mhm.
So that's the area of the base. To find the volume, you're going to multiply whatever this number is times the height, which happens to be 8. So let's get some of these numbers for you times. All right, so I get the area of the base is 110 inches squared. The volume is 110 times the height, which is 8, or 880 inches cubed, or cubic inches.
Okay. So would the 8 for like the height, would that be like the side length too?
The 8 on the left is the height. That's
Okay.
your value of h. It's a
Mhm.
little odd because it's, I don't know, maybe where it's positioned. I mean, we don't really look at pentagonal prisms very often in this world, but that is what it is.
Okay, cool. Do you want to move on to 8.1 from the email?
Yes, we can do that. Does that cover everything on that worksheet you sent by text?
Yeah, I have no more questions on that.
Fantastic. Yeah, so 8.1, I can grab question 3 and we can start with that. The figures below are similar. What is the similarity ratio? Okay. So small issue here is we don't know which direction we're going.
Mhm.
I assume we're going left to right, but it does affect the ratio. Because in one way it's getting smaller. If you go the other direction, it's getting larger.
Mhm.
Do you have any way to know if that is correct? Because a bunch of these look like they're going to be very similar to that. See how number 6 has an arrow on it, that if you go further down, it
Oh
tells you.
yeah.
This one doesn't. Is there anything I'm not seeing that maybe would?
I don't like I missed the lesson, and so I don't really know which direction it goes in. But
Okay,
it probably goes left to right.
hopefully it's like reading and it's left to right. All right, now the way to do this is you sort of identify two side lengths that you know are similar. This should give you more information. Like, they really should tell you that this 24 side is similar to the 20 side, but you're writing an equation. It's like 24 times some constant equals 20, and you solve for this value of k. So we will divide by 24 on both sides. So k equals 20 divided by 24, but you reduce this fraction. You can divide the top and bottom by 4. So that ends up being 5/6. So it says as a fraction a over b. That's a pretty good indicator, excuse me, that we were on the right track there, that it would be
Oh, okay.
5/6.
And you just divided by 4 to simplify?
Yeah, you, I'm sorry, say that one more time. Didn't quite understand.
You just divided by 4 to simplify, right?
Yes.
Okay.
I assume it would not take that. It wants the lowest form.
Okay.
Any questions on that?
No.
All right, let's move on to number 4. All right, so we'll again presume we're going from left to right, and perhaps based on the previous one, I gave you the impression you could arbitrarily choose which sides to make similar. It's not that way. You have to kind of line it up. It'd be nice if we could rotate these figures
Mhm.
to make them look the same. But like, for example, notice how there's like a 3 and a 1.
Yeah.
You want to identify the same thing over here, the 3 and the 1.
Mhm.
So that tells you that the 15 goes to the 6.
Okay.
So just like in the previous problem, it's 15 times k goes to 6. Divide by 15. K equals 6 over 15, but you divide by 3, and that's 2 divided by 5. So before you say, okay, I've got it, that's my answer, we should check. We should check, like, does the 10, which is between the 1 and the 2, go to the 4, which is between the 1 and the 2? Basically, if you take that 10 and multiply it by k, which is 2/5, does that equal 4?
Oh, okay, I get what you're saying.
Like, we should check that. And it does. It does. I mean, you can grab a
Mhm.
calculator, it does. But you should check, because like, what if it didn't? That means you've chosen the wrong side, or maybe made an error somewhere. And then you should
Mhm.
similarly check that 18 goes to 7.2.
Mhm.
And it does. So we know, in fact, that 2/5 is the ratio there. All right, moving on to number 6. All right, so we're going from the left to the right. It's kind of reasonable to presume that the 4 goes to the 6, or the 7 goes to the 10.5, or the 10 goes to the 15. You do want to line them up, though, if you're unsure. So
Mhm.
just like the previous problems, 4 times k equals 6. K is that similarity ratio. Divide by 4. Divide by 4. K equals 3 divided by 2. And then we hope that it works for the others. So you'd want to check, is 10 times 3/2 equal to 15? Is 7 times 3/2 equal to 10.5? You will find that they do both, in fact, work.
Mhm.
Any questions on that?
No.
All right. Okay, just looking this over here. They're telling you this symbol right here, this symbol right here means similar in math.
Mhm.
And they're saying CDE is similar to FGE. So the order of the letters actually matters here. So like where are D and E in the ordering? So notice that D comes before E. That means it goes with G to E. So
Mhm.
it's the 6x plus 3 that are similar. There's some sort of a way to go from 6x plus 3 to 17. It's not that 6x plus 3 goes with like 21, for example.
Mhm.
Okay, so that's why it's a little bit awkward. So these go together, and then these go together. Now, you're normally used to setting them equal to each other. Like, sometimes you just say, okay, 6x plus 3 equals 17, but they're not equal. They're similar, so they're in ratio. So a couple ways to do it. We can do this where we put the 17 on the bottom, but then we have to put the other variable expression over here on the right. And unfortunately, we do have to solve this kind of awful thing here. Do you remember how to do something like this from previous class?
Not really.
All right, fair enough. You multiply diagonally. Okay, so
Oh,
you
I
take
hate
that.
doing this.
Yes, 21 times 6x plus 3 equals, and then you go the other direction, 17 times 8x minus 1. So you need to grab a calculator, make sure you get all the multiplication stuff correct. You got 126x plus 63 equals, and then 17 times 8 is 136, x minus 17. Add 17 to both sides. Subtract 126x from both sides. And believe it or not, it actually works out kind of nice. It ends up being 80 equals 10x.
Mhm.
Divide by 10, x equals 8. Now the next thing it asks for is the length of CE. Always good to kind of just identify what it actually is that it wants there in the triangle. So CE is 8x minus 1, but you know the value of x now. 8 times 8 minus 1 is 63. Give me just a moment, please. All right, sorry about that. I am back.
Oh, it's really good.
Okay. Any questions on that?
No.
All right. All right, use the given information to find x, then find the identified segment length, so on and so on. Okay. So they're giving you these two triangles, but they're one's like kind of rotated. So the E really goes where the B is, the D goes where the A is, and F is where C is. Is that okay?
Yeah.
So when you recognize that, you realize, okay, 4 goes to the 6, or the 6 goes to the 4, depending on how you want to look at it. And similarly, well, actually we don't know. We just know that the 8 goes to the Y, and then the X is the X and the 7 are the ones that are related here. So you want to find the relationship, like how do you go from 6 to 4, or if you want to go the other way, 4 to 6. So 6 times k to 4, just like we did in the first few problems there. K is 2/3. So when you're going from the one on the left to the one on the right, you multiply by 2/3.
Mhm.
All right, so to find x goes with the 7. It's 7 times k equals the x value. And you know k now. K is 2/3. Is that okay?
Yeah.
So that it ends up being a fraction, 14 over 3. You can go to your calculator. It says to round to the nearest hundredth, so 2 decimal places. So it looks like that would be like 4.67 maybe.
I think so. Yeah.
All right. To find the length of CE, CE is not in this drawing. Oh no, it says Y. Okay, sorry. I was like, what is going on? To find Y, use the blue. 8 times K equals Y. We know that K is 2/3, so 8 times 2/3 is 16 over 3. That's 5 1/3, 5.33.
Okay.
And this was 9, wasn't it? I skipped 8, didn't I?
Yeah.
All right, let's go back and do 8.
Oh wait, before we move on, so you divided by 3, right?
Yeah, yes.
Okay. That's all
Yes.
right.
Yeah, always interrupt me if anything's unclear. In the virtual setting here, I can't see you to know your body language, to know if there's questions. I just have to go off of verbal responses. So, All right, we've got, yet again, big surprise here, another triangle. How do we want to do this? So sometimes it's better to look at the letters, like it says T to L matches up with C to H. So T to L is 25, C to H is 10. Okay. So that's an important relationship that you're going in that direction there. Similarly, it looks like L to Y goes with H to K. So L to Y is this one, H to K is this one. So we could set up another one of these proportions. That's probably the best way to do it. Unfortunately, it's not, well, I take that back. Why don't we do it the way we've been doing? Let's do the K thing, because I think that's probably gonna be more clear for you. So
Yeah, I like that better.
25 times K equals 10. That's going from this one on the left to the one on the right. Divide by 25. K equals 2/5. Divide both of those by 5. So what that means is to go from Ly, which is 4x minus 1, you will multiply that by 2/5 to get the right-hand side, which is x plus 5. So unfortunately, you don't get out of solving an equation, but maybe this is okay.
Yeah, I like this way a little bit better.
All right, good. Generally a good idea to get rid of the fractions first. So we're going to multiply everything by 5. So this times 5, and then everything on the right by 5. So on the
Could
left,
we,
go ahead.
oh, sorry. Could we multiply everything by 5/2?
You can, but then you have a fraction over here on the right. And that's what I'm trying to get rid of, because fractions are bad. They just make things more difficult here. So you'll see that the fractions do go away in this step here, because you're multiply 2 times the 4x minus 1, 8x minus 2, 5x plus 25. Okay. So we're going to subtract 5x from both sides. So that's 3x minus 2 equals 25. Add 2 to both sides. 3x equals 27. And divide by 3. So x equals 9. And that's the first box. You got to find x. So x is 9. To find Ly, you put 9 back in for x into this equation here in the blue circle. So it's 4 times 9 minus 1. Ends up being 35. All right, so I think that's everything from that worksheet.
Okay, I think so too.
Okay.
Do you want to move on to 9.1?
Yep, let's see what you got there. Just take a look at what you've got here. Okay. Got it. All right, so let's just start with number 1. All right, number 1 here, square root of 150. You're going to build what's called a factor tree. Have you heard that before, or a factor ladder?
Yeah.
Okay, so in this case, you start with the smallest prime number, which is 2, and you're dividing 150 by 2. So 150 divided by 2 is 75. You try 2 again, you find that 2 does not work. So you go to the next prime number, which is 3, and 3 does work. 75 divided by 3 is 25. You try 3 again, 3 does not work this time. You go to the next prime number, which is 5. 5 does work. And you stop when you get prime numbers on the outer edges here. So these are all prime numbers. You look for pairs. So I like, my socks match. I know that's not always a thing, but pairs are matching. They have to be the same in this context. Okay. For everyone that's matching, you bring one out. So you bring a 5 out of the root. Notice the 2 and the 3 don't have anything to go with it. They don't have any pairs. They stay in.
Mhm.
So your answer is a part that's out, and a part and part of the answer is in. In this case, there's a 5 that comes out, a 2 times the 3 that stays in. So your answer here is 5 square root of 6.
Oh, okay, I see that.
So you're looking for these pairs. Now, normally I would do a bunch of examples with you like this. I know our goal is just to get caught up here, but there's way more to this than just this simple example. But we'll just keep doing the problems in order, and see what things come out of it. So let's do number 2. Go to number 2 here.
Mhm.
All right, so notice there's a square root of 24. That's kind of like the last problem. This -6, just ignore it for the moment. We'll deal with it at the end. We're going to do the same thing. We're going to start with 2, and we're going to see, well, does 24, is it divisible by 2? Yes, it is. 2 times 12. And then you try 2 again, and look at that, it works again. 2 times 6. And this is like what we do in real life. Like if something works, you just keep doing it. You do it over and over again until it doesn't work anymore. Right? You stop when you get prime numbers on the outer edges here. And then you look for pairs. So see how there's a pair of 2s here?
Uh-huh.
You bring a 2 out, just one. There is nothing to go with the 2, nothing to go with the 3. So those stay in. So your answer to this part is 2 square root, what's left over on the inside, 2 times 3, or 2 square root of 6. But that's just the part, that's just the square root of 24. What we have here is just this part. So you bring that -6 down, times 2 square root 6, and you multiply these together. So that becomes -12 square root of 6.
Oh, okay. Is that the final answer for
That's
that?
it. Yep.
Oh, okay.
All right, let's look at number 3. All right, so we've got square root of 6 times the square root of 27. There's this property that says if you have the square root of a times the square root of b, this equals the square root of a times b, which means we will be multiplying 6 and 27 together. I know it makes it worse because the number gets larger, but this is probably the best path to go down here for this. So it becomes the square root of 162. And then we treat the problem just like we did the previous one. So we're going to build a factor tree. So start with 2. Is 162 divisible by 2? Yes. 81. But this time 2 does not work. So you go to the next prime number, which is 3. 3 works, 3 and 27. So you try it again. 3 and 9. And then you're like, okay, keeps working. I'll keep trying it. 3 and 3. So you circle pairs. You got a pair of 3s, you bring one out. A pair of 3s, you bring one out. There's nothing to go with the 2, so it's going to stay in. So you brought a 3 out, you brought a 3 out, square root of what's left over on the inside, which is 2, or 9 square root 2.
Okay.
All right, so I think we've got the first one's done. So number 4, we'll just kind of rework here, kind of the way we've been doing. So number 4 is the square. Is it the square root of 18?
I'm pretty sure, yeah.
Just zoom in here on the. Yeah, it is. Okay. And then times 3 square root of 8. So if we just reorder this slightly, 3 square root of 18 times the square root of 8, we can do the same thing we did in the last problem, which is multiply 18 times 8, which ends up being a square root of 144.
Mhm.
Now this one should jump out at you. This one's a little different than the others. The square root of 144 is it's nice, it's known. There's a number that when you multiply by itself, you get to 144. That is 12. 12 times 12 is 144. So this one
Okay.
works out perfectly. Like you don't have to worry about reducing this.
Okay.
Okay, so 3 times 12 is 36. That's your final answer.
Okay.
All right, so let's look at number 5.
Okay.
Number 5 is the square root of 96 over the square root of 3. There's a property here that's fairly useful, is that when you have 2 square roots in the top and bottom, you turn this into square root of a over b inside the square root. So it's 96 divided by 3. And you might wonder, well, why would you do that? Sometimes this works out. Like sometimes you can actually divide them, and that's when you would choose this. So this ends up being the square root of 32. Now we're not done, but that's better. We're slowly approaching the final answer here. So break apart the square root of 32 just like we've been doing. Start with 2. 2 and 16, 2 and 8, 2 and 4, 2 and 2. And then you look for pairs. There's a pair. There's a pair. But there's nothing to go with this last one, so it's going to stay on the inside. So on the outside, you have 2 times the 2 for those that come out, and then there's a 2 that stays on the inside. 4 square root 2, like that.
Okay.
All right, let's go. So 6, 7, and 8, they transition. So these should actually say something different in them, but these are what are called now rationalizing problems.
Mhm.
And the reason they're rationalizing problems is because there's a square root on the bottom. So there's like all these preferences in math. There's like, don't leave a fraction in the denominator. This is another preference, like don't leave a square root in the bottom. All right, and you're like, well, what do I do? Well, you have to be told this, but you multiply the top and bottom by the root. Whatever the root is on the bottom, you multiply the top and bottom by that.
Mhm.
So on the top, this becomes 42 times the square root of 7. Like what you cannot do is multiply these two numbers because only one of them is under the square root. On the bottom, we did a couple of these already. You can multiply the 7 and the 7 because they both have a square root. That's the square root of 49. That should look familiar to you. You should say, oh, I know how to reduce that. The square root of 49 is 7. Is that okay up to this point?
Yeah.
Next is you look to see, can these two numbers outside of the square root reduce? Can you take 42 and divide it by 7?
Yeah.
I agree. It becomes 6 square root of 7, and that is your final answer.
Ooh, okay.
So Rationalizing means to multiply the top and bottom by whatever's on the bottom. The bottom always becomes a number. You don't get a square root out of it, and you don't have a square root anymore. It becomes it reduces. And then if you can, you simplify.
Mm-hmm.
All right. Let's move on to number 7 here. Okay. Okay, what should we multiply the top and bottom by in this problem?
Wait. You would multiply it by the radical of 2.
That's right. Now in the numerator, there's nothing to do. You just rewrite it. But what does the denominator become? What's the square root of 2 times the square root of 2?
4.
It is 4. It's the square root of 4.
Oh, yeah.
And does that reduce?
Yes, to 2.
To 2. And just like the previous one here, you can divide. What is 8 divided by 2?
4.
4 square root 2.
Had me struggling.
Well, you are sick. You don't want to overdo it here. It's like going to the gym. You gotta start back on the easy weights. All right. Same thing here. You multiply the top and the bottom by the square root of 6. So this becomes 15 square root of 6 over square root of 36. Square root of 36 is 6. That works out nicely. The top is still 15 square root of 6. Now in all the previous problems, this has worked out nicely. Like it just became, 4, or it worked out to, what did we have in 6? We got 6. But you can still reduce 15 divided by 6. They're both divisible by 3. So you can divide both the top and the bottom by 3. It becomes 5 square root 6 over 2, like that.
Oh, okay.
What you cannot do, can never do, is divide in the root like that.
Oh, okay.
All right, so the next grouping of problems is built upon what we've just done. It's like we're going to do a different problem, but we're going to reuse some of these skills. We're either going to reduce some roots like we did here. We may have to rationalize like we did here. Like everything is fair game up until now, but with these problems. So it's like, hopefully it was clear, because if it's not, it's going to, we're going to need some more practice. So we'll just do a few problems here and see how this goes. Let's start with number 9 here. All right. So 9 is a right triangle. We know it's a right triangle because of that symbol there. A right triangle has 2 legs, A and B. The legs come out from the 90-degree angle. Like maybe you can visualize a body and there's 2 legs coming out. You need to, but somehow you have to remember that these are legs. Okay. The third side, C, is the hypotenuse. The side across from the 90-degree angle is always the hypotenuse.
And that's what we see.
Always C. Now it's called X in this problem, but A squared plus B squared equals C squared. That's probably what you've remembered from other classes. It refers to A and B being legs and C being the hypotenuse. So we have A is 18, B is 24, C is unknown. Do you have a calculator handy for us today?
Yes.
All right, what is 18 squared?
18 squared, 324.
Good. And do 24 squared?
576.
Okay, go ahead and add those together.
$900.
Okay, now take the square root of both sides, and hopefully it works out nicely.
Okay. 30.
30. Okay. All right, so let's look at what it's asking for in 9 through 14. It says to solve for X. Have we done that? Do we have the value of the hypotenuse? Yes. It says to answer in simplified radical form. There's no radicals, so we don't have to do anything with that here. Last question is, does this form a Pythagorean triple? So a Pythagorean triple is when A, B, and C are nice. They're integers, are natural numbers. In this case, yes, it is. 18, 24, and 30. Yes, this is a triple.
So it's just a triple if it has 3 numbers?
They have to be whole numbers.
Oh, okay.
Like you'll see that most of these are not, but we're going to do another one that is. So let's do 13 because it works out nicely. In fact, it's very, very similar to what we just did here. So I'll label it here for you, but the legs are A, B, and C like this. So this is A squared plus B squared equals C squared. Will you try solving this for C? It's basically the same as what we just did, just different numbers.
Oh, wait, give me a second. I need to like draw it out really quick.
Okay.
So A obviously 81, and then plus it'd be 1600
Okay, keep going.
equals x squared, and then you add those together. So 81. And then, oopsie, I just threw my pencil. And then you put that under a radical.
Yes.
So that would be 41. X equals 41.
Yeah, so this one works out nicely again. You see that? Like A, B, and C, 9, 40, and 41. And you might think, well, geez, do they all work out nicely? And the answer is no. Most things in life don't work out, as well as we think they should. This is just another example of that. But the more we do, the more you'll see that. But we will do one more that does work out nice. This one's kind of different. We're going to go to 11.
Okay.
So I think it's helpful to see like a number of problems in a row that work out nicely, so you get a feel for that.
Yeah.
So this time A, B, and C, if we draw the A and B around the legs, X is really A. We're used to X being there, but it really could be in any position. So this is A squared plus B squared equals C squared. We don't know A. A is the X, B is 20, and C is 29. So this is X squared plus 400. Can you tell me the 29 squared, please?
29 squared is 841.
841, very good. How do we solve this equation? What should we do here to get X?
Subtract 400 from 841.
Good. Anything left?
And then we have to put the 441 under a radical.
That's right.
And then we get 21 for X.
Yes, so X is 21, very good. So this is another triple, another one that works out nicely. I believe this is the last one in this homework assignment, but good. It's nice to have a few that work out, real well. Okay, let's go to 10. 10, yeah, these are all kind of the same, but now we're gonna have to do some stuff with roots. So let's take a look at that. All right. Here we go. So we got A, B, and C. A squared plus B squared equals C squared. 7 squared plus 7 squared equals X squared. This is 49 plus 49 equals X squared. 98 equals X squared. So if you went to your calculator and you took the square root of 98, you would find that it's a decimal that doesn't repeat.
Yeah.
And in that case, you know that you need to actually do it another way. You have to reduce the root, which is what we were doing earlier.
Oh,
So you start with 2. You always start with 2. 2 is the only even prime number, works a lot. So try it. So 2 and 49. 2 times 49 gets you back to 98. Does 49, is it divisible by 2? No, doesn't work with 2. You try 3, doesn't work with 3. 5, it doesn't work, but it does work with 7. 7 times 7 gets you back there. So you bring a 7 out, but the 2 stays in. Right, so the square root of 98 becomes 7 on the outside, square root of 2 on the inside.
okay, perfect.
And that is the value of X, 7 square root 2. So this one is not a Pythagorean triple. It's not a whole number. That's, one reason for that. Okay, let's take a look at number 12.
Wait, 13, right?
We've been doing these out of order so that they're kind of the same. We started with 9. We
Oh,
jumped to
okay.
13. Then
Okay.
I went back to 11. I know that disrupts like the normal flow, but they should be done in this order where you see the same type of problems. You get a familiarity with how to do it.
Okay, no, I got you. Thank you.
And now we're back to 12.
Okay.
So we've got A, B, and C. A squared plus B squared equals C squared. A is X, B is 12, C is 14. So 12 squared is 144. 14 squared is 196. Subtract 144 from both sides. So this is X squared equals 48. Does that look? No. That's really bad. 52. 52. Okay, so now we're going to take a square root of both sides. On the right here, you have to start with 2. Square root of 52 doesn't work out perfectly, so you have to reduce the root. 2 and 26, 2 and 13. Because there's a pair of 2's, you bring one out. So that's 2 square root of 13, like that.
Okay.
Any questions on that?
No.
Okay. All right, we'll probably get through 14 and that'll close out our lesson for today. I know we've got another lesson, I think, on Saturday, so we'll just pick up wherever we finish here.
Oh, yeah.
So same thing here. I know it's a rectangle, but it's really a triangle. A, B, and C. A squared plus B squared equals C squared. 13 squared plus 6 squared equals X squared. So the faster you are at calculating the squares, the faster these problems go. You can use a calculator if you want. It doesn't matter to me. You should use a calculator if you're allowed to. So this is 205 equals X squared. And I'm pretty sure that this is a perfect, I'm sorry, this is a prime, so it does not work out. Let me double check that though.
I didn't get perfect answer.
Yeah, this one doesn't even reduce though. It's like there's nothing that goes into it. Yeah. So occasionally, like, because if you try like 2, if you tried, 3, 4, 5, 5 works, but you get 41, and that doesn't. 41 is definitely a prime. So sometimes it's that's it. You get like, all right, square root of 2 of 5. That's my final answer. So just kind of looking ahead here, it looks like, just if you're planning here, the next little bit here, doing more of the same, but definitely want to send over some new stuff for Saturday for us to work on. Are you getting closer to getting caught up?
Oh yeah.
Fantastic. It's awesome. All right, well, let's go ahead and stop here.